Let's turn our attention now to Process Explorer, which is probably the most well-known tool in the CCInternals suite. So here's Process Explorer. We can see there's a 32-bit version which actually contains the 64-bit version within it, or we can launch the 64 version directly. Now, an important thing to note is that you can launch Process Explorer with admin privileges, or as standard user, I recommend you always run it with admin privileges. And you can go to the properties of this executable, and the compatibility tab you can specify you would like to run it as administrator always by checking this box and pressing OK. So now when I double click, it's going to launch with admin privileges, and when it does so, it has more power. It can show us more information. So once Process Explorer launches, it looks something like this. So you can see here when you start Process Explorer for the first time, you see a bunch of processes here in a tree-like view, or at least multiple trees in fact. And we have various colors here that are shown. And so at first glance, it might seem like an enhanced version of Task Manager. Indeed it is. It has many more columns than exist in Task Manager. If I right-click the columns area and go to select columns, you can see there are many columns here that are spread around multiple tabs to make it easier to locate what you're looking for. So for example, if you want to look at counters related to memory, you can go to the Process Memory tab and grab some of these counters here. So there are more columns here than you can find in Task Manager. And then there's these colors. So let's look at the colors first. These colors mean something. Every color represents some kind of property for the process in question. The entire list of colors is available in the Options Configure Colors menu item here. So you can see all the available colors, and you can check or uncheck every color you might be interested in. And so I actually checked here the Protected Processes color, which is not checked by default. So once you have these colors checked, the colors that you'd like to see, you can then look at various processes based on that color. So let's examine some of these colors. And first I'm going to sort here by name to make it a bit easier, turn that into a list, and we'll talk about the tree-like view very soon. So the first color we might be seeing here is this, perhaps the cyan color. So this cyan color is used for UWP applications. So essentially applications that are the ones that you can suspend, for instance, when you minimize them and things like that. So notice that if I look at calculator, let me find calculator again, it is shown here in gray because it's currently suspended. This is yet another color Process Explorer supports. But if I go ahead and restore that, it will turn into this cyan color. To be more precise, the cyan color is about processes that are hosting the Windows runtime. They use the Windows runtime APIs, which are the ones that are used to build UWP applications, but they can be used for other purposes as well. And that's why we can see something like Windows Explorer here, always also shown here with the cyan color. Does that mean that if I minimize one of the windows of Explorer, it becomes suspended? The answer is no. But Explorer does use the Windows runtime APIs, and that's why it's shown in cyan. To be even more precise, the API used behind the covers is called isImmersive Process. And isImmersive Process was created in the Windows 8 days when these kinds of applications started to appear. And in the Windows 8 days, if you remember those applications, they were called Metro applications back then, they were always full screen. So you had that kind of immersive experience, or at least you should have had an immersive experience. And this is where the function name isImmersive Process is coming from. And that's what this cyan color represents. Now there's another color that I wanted to show you here, which doesn't seem to show here, a yellowish color. So let me fire up Visual Studio. And Visual Studio is a .NET application. And .NET applications that are using the .NET CLR are going to be shown with a yellowish color. So you can see one of those is this Perf Watson 2 here, process that was created as part of Visual Studio. The Visual Studio itself, the process is called devenv.exe, that's the process name, and you can see it is with a yellowish color. If I double click any one of these .NET processes, we can see the properties of a process, and for .NET you can see there's a tab here called .NET Assemblies and another tab called .NET Performance. So with .NET Assemblies you can see the list of all the modules loaded into the address space of this process from a .NET perspective. The term assembly means .NET module. It's kind of an unfortunate term, but this is the term used by .NET. .NET Performance here shows a bunch of performance counters as they relate to various categories which might be interesting for people trying to diagnose .NET issues in a process. And this view is actually updating every second with new data if that is applicable. And so .NET processes, are going to show these two tabs, and for processes that are not .NET processes, these tabs will not show at all. So these tabs are contextual. For example, if I double-click Explorer.exe, you see these .NET tabs disappear, don't really exist here, because currently Explorer.exe here, this particular process, is not hosting any .NET assembly at this point. It's not hosting the CLR at all. Looking at other colors, we have this pinkish color. So this pinkish color is for Windows services. What is a Windows service? The term service in general is highly overloaded in the security in the software industry, really. And in this case, it means a process that can run automatically when the system starts up and can run in one of the special users that Windows provides, the local system, network service, and local service, and can also be managed, and in fact is managed by the service control manager. So the service control manager can start services, can stop services, and manage them in various ways. If I double click any one of these processes with this pinkish color, we can see there's a tab called services. And this shows us the service or services hosted in this process. Just like in .NET, the services tab here is contextual. It will not appear for processes that are not hosting any services. Now, as you can see here, there's this executable which seems to be abundantly here everywhere, called svchost.exe. This is known as a generic host for services that is used by Microsoft for most of the Windows built-in services. And because this is a generic process or generic executable, the services themselves have to be implemented as DLLs. And you can see here the path to the DLL implementing this particular service here, which in this case it's the Hyper-V time synchronization service. So every one of these processes, if you double click them, you can see the service or services that are hosted within. Now, you might even see services that are hosted in their own executable, which is perfectly fine. Here's SQL Writer, another service here that is actually the SQL Server, the virtual VSS writer. That's the volume shadow copy service, something we won't be discussing in this course. So in any case, this is an executable, so it's implementing the service directly without using any associated DLL, which is perfectly fine. In fact, when we are creating our own services, we create our own executable. However, it is interesting to understand what the SVC host looks like and what's its purpose. Now, one of the ideas behind the SVC host is the ability to host multiple services in the same process to conserve system resources, because the existence of a new process has an overhead, creating the kernel object to manage the process, the address space, the handle table, all these things, they take up memory. And so in earlier versions of Windows, before Windows 10 version 1703 in fact, what Microsoft did, it tried to bundle multiple services with a smaller number of processes of type SVC host. This is a good idea for conserving memory. However, it has its downsides because all the services are part of the same process. So if one service misbehaves, for example, causes an exception, then the entire process shuts down, not just that service. So all the other services that happen to share the same process, they will shut down as well, which is kind of unfair. And perhaps that kind of dependency is not ideal. And if you have the case where that process is, for example, leaking memory or consuming even lots of memory, it's not easy to figure out which of these services is the actual culprit. That's the one that's responsible for that large memory consumption. And so starting with the version 1703 of Windows 10, of course going to Windows 11 as well, if the system has at least 3.5 gigabytes of RAM, then most of the services will be in their own process for robustness purposes. So now if a service misbehaves in some way, it's going to be affecting its process only and essentially its own service, and that's it. There will be no other effects on other processes or the system. There are very few SVC hosts that actually are hosting